Hello everyone, in this section we will introduce you to the Data Development module. We will give you a brief introduction to the data development functionality, so that you can quickly understand and implement your first data development task. First, let's introduce the Data Development module. Data Development module supports cross-data source, cross-system, cross-business data extraction, transformation and loading in the visual interface, and can automatically run scheduled tasks through the scheduling function, which can help you easily build an offline warehouse and ensure the efficiency and stability of data production. We will introduce to the 4 aspects of data sources including task management, task development, task scheduling and task O&M. First, the Data Development module supports multiple data sources, allowing for data processing and integration from various sources. Data sources include relational data sources, non-relational data sources, interface data, file data, and so on. Task management can storing the designed business process by scheduled task and managing scheduled tasks by folder. Next, let's introduce the Task Development module. First, we'll explain the specialized terms. The concept of a node is the basic unit of a scheduled task. For example, the data synchronization node, data transformation node, SQL script node, etc. Multiple nodes are connected to determine the execution process and then form a complete scheduled development task. For example, from parameter assignment to conditional branching to message notification. According to the dependency relationship between the nodes, each node is run sequentially. Steps are composed of individual nodes. Step flow is also called workflow. Workflow is the arrangement of steps. Each step is relatively independent. Only define the order of execution. Do not involve data flow. For example, parameter assignment is a step. Parameter assignment to conditional branching to message notification is a workflow. The following introduces the concept of data flow. Data is processed through ETL stages using data transformation nodes. We have a prepackaged, user-friendly visual interface that allows for efficient data cleaning, processing, and loading. The data flow provides various types of operators, which can complete the data input, output, conversion, and other operations. There are various functions within the data development. For example, the general synchronization node use data synchronization/data transformation to synchronize data across repositories and perform data cleansing calculations. FDL supports various types of file transfers for downloading/uploading files. The supported methods include API download/upload, local, and FTP/SFTP servers. Script class node can be used. For example, Python script, shell script, etc. Process nodes for complex logic can be combined with general-purpose nodes for complex logic processing, such as conditional branching, loop execution, output result transfer, and other complex process control. The task development interface is also very user-friendly and a task can be quickly realized by dragging and dropping components. In addition, an intelligent SQL editor is provided. For task scheduling, we support task control and scheduling plan. Support to set task timeout limit, whether to rerun after a task fails to execute. Support to set scheduling task priority, result notification, and so on. Also, you can set the start date and execution frequency of scheduling plan and so on. Task operations and maintenance can be flexibly scheduled in batches and monitored for their running status. More convenient operations will greatly reduce the workload for maintenance personnel. Now, let's look at other capabilities for data development. We can manage permissions by controlling both interface functionality and data access rights through the user interface. Additionally, external systems can trigger scheduled tasks via APIs. The following describes the data development process. First, configure data sources for data reads and data writes. Then start the scheduled task development by dragging and dropping nodes. Next, debug the task by executing the task manually and performing task debugging based on the task run logs. Once the task can run successfully, publish the task and set up scheduled task to schedule the execution. Finally, perform task management and resource control of the scheduled tasks. The following describes the steps required to develop the first scheduled task. The first step is preparation of database. Create a new data connection between the database and find data link. The second step is creating tasks. Create folders and tasks in the data development interface. The third step is design tasks. For example, if we want to extract all the product data from the SQLite database to the MySQL database, and add a new table in the MySQL database to store this data. This can be achieved by using the data synchronization node. The fourth step is to test and debug. Save and run the design tasks in development mode. We can judge whether the task is correct or not by checking the task running log and debug it. The fifth step is scheduling configuration. Once the task is designed, we need to publish into production mode and configure the scheduling cycle for the task in production mode to ensure the timeliness of the data. The sixth step is task O&M. Through the scheduled task operation and maintenance. View the task running status, running time consumption, and other information for task management. Next, let's look at a specific case of data development. After logging in FinDataLink Data Integration Platform, select System Management, Data Connection, Data Connection Management. To establish the connection to the source and target databases. First, we create a SQLite data connection to be used as the source data connection. Click New Data Connection. You can search for the data connection type on the right-hand side. Then enter the data connection name. Select driver, database name, host, port, username, password and other data connection information. After test connection, click Save. Then create a data connection to the target database. That is, MySQL data connection. Click New Data Connection. Select MySQL. Enter data connection name. Then select driver, here we select default. If we need to customize the driver, you can select custom here and upload the driver manually. Enter database name, host, port, username, password and other relevant information. Then click Test Connection. Click Save when the connection is successful. Go to Data Development Module. Find the specified folder. This is the folder we have edit permissions. Now go to create a new scheduled task. The editing interface of a scheduled task is in development mode by default. Development mode is equivalent to the test environment of the task. Users can edit the design of the task. All changes will not affect the tasks in production mode. Production mode is a stabilized version of the task. After we edit the task in development mode and publish it, we can view the task in production mode. We can also set up a timer based on this version. In development mode, select the data synchronization node. Select the source database we just created. Data Connection F or Demo. Here we can search the data table. We will use the SQL configuration here. Click on Data Preview. You can see the data table of our S product has been extracted. Then set the data destination and mapping. While means selecting the database of the destination. The data connection is FDL_Demotest we just created. Select the demo test database. Then you can choose existing table or auto creating table. For example, we create a new product table here to store the data. Since we are creating the table automatically, The target table and field mapping corresponds to the source table field. We can also manually change the name of the target table field, as well as the type, remark, and so on. Setting the right method. Because we are directly creating a new table here, the default right method is wrt data target after emptying it. After setting, we can save and run the task first. We can see the result and make adjustments. You can see that the log shows that the task ran successfully. The data has been successfully transferred to the target database. Then we can find the synchronized data table product in the target database. At this point, we can click Publish. Publish the tasks edited in development mode to production mode. In production mode, we can set up a scheduling plan. For example, we want the task to be updated once a day to ensure the timeliness of the data. Then we can set up a single schedule task. In Scheduling Plan, enter the name of the target database. Then select the start time of the task as today. Execution frequency is execute repeatedly, which means execute the current task once a day. Here you can set the end time. We choose indefinite duration to execute the task every day. Then we can also check the operation and maintenance status of the task. We select Task O&M. Under Scheduled Tasks, you can see a running record logs of the corresponding task. For example, let's search task name to see its scheduled running history. We can click View Details to see the current running record of a task. You can also manage the scheduling plan in batches. For example, if we select the scheduling plan, Task Schedule, you can see the scheduling plan we just set up. We can manage tasks in batches or directly view the status of the scheduling plan. It also supports direct editing and other operations. In Task Management Interface, you can also directly find this task. You can see whether it has enabled scheduling, whether it has been published, or if it has a timeout limit, etc. Timeout limit, retry after failure, and result notification are all set in our development mode. Make a task control setting. For example, you can set result notification. That is, when the task is abnormal, the system can send notifications to the specified platform users, or notify the specified user when there are dirty data in the task.